Hello everyone. This question has been taken from Irodov Fundamental Equation of Dynamics question number 66. The question says a small body A starts sliding down from the top of a wedge from this point whose base is equal to L is equal to 2.1 meter. The coefficient of friction between the body and the wedge surface is K 0.140. So coefficient of friction between body and the wedge surface is 0.140. At what value of the angle alpha, this angle alpha, will the time of the sliding be the least? So what will it be equal to? So let us solve this question. So this diagram we have made with all the forces acting on the body for our computation purpose. This L is equal to 2.1 meters given. The coefficient of friction between the body and the surface of the inclined plane is given. K is equal to 0.140. We are to compute for or calculate for the angle alpha for which the time of sliding from A to C will be minimum for this body. Let us notate the time as T min like this. We assume the mass of this body is m. Okay. Now you see what is happening here. Your L is fixed. So only AC line, AC distance will keep changing when alpha is changing, right? If alpha is more, the AC will be like this, right? If alpha is less, the AC will be like this. So means the length of AC is changing. At the same time, when alpha increases, you can see here that sine alpha will increase. Means gravitational pull along the inclined plane will be increasing. But the gravitational pull perpendicular to the inclined surface is depending on cos alpha. So alpha increasing, so cos alpha will decrease. So this force will decrease. And if you see, there is no motion involved perpendicular to the inclined planes. So normal reaction force by the inclined plane to the body N will always be equal to mg cos alpha. So what is happening? Your alpha is increasing, cos alpha is decreasing, so your normal reaction force will be decreasing. But you know that the friction force when the object slides on the surface is equal to the coefficient of friction between the surfaces and the normal reaction force. So K into N, right? So it means mg cos alpha is decreasing, so friction force will also decrease. Okay. So we have to find now, okay, alpha. So from right angle triangle ABC, if you go, what is the length of AC? AC will be L sec alpha. You can easily find out, like cos alpha will be your L by AC, and from that equation AC will be equal to L sec alpha. For the convenience, we have taken the y direction as perpendicular to the inclined plane and x direction along the inclined plane. So we will apply Newton's law of motion on this body along the y direction. So the y direction, only two forces are acting, one is N, one is mg cos alpha. So all the external sum of all the external forces in the y direction is equal to N minus mg cos alpha and will be equal to m into ay, means acceleration in the y direction, but there is no motion in the y direction, so ay is 0. So therefore n is equal to mg cos alpha. This is your number one equation. Friction force, you know that k into n, so k into mg cos alpha, right? So this equation also you got. Now we will write the equation of motion or Newton's law of motion in the x direction, means along the inclined plane. So sum of all the external force in the x direction is equal to mass into acceleration in the x direction. Let us say that is A, we have notated as A. So what is so which all forces are acting in the x direction? One is your mg sine alpha, and one is friction force. Friction force is opposite to mg sine alpha direction, so it is minus f is equal to m into a. So acceleration is g sine alpha minus k into g cos alpha. This is number 3 equation you obtained. A question comes in the mind of the students that okay, if the acceleration will be maximum, the distance, the time covered is from A to C will be minimum. Here the students can get confused, and they can do it that okay, differentiate it with respect to alpha and put the value 0 and calculate the value of alpha. But that will be a wrong thing, because what is happening, acceleration will keep on rising when your alpha is increasing, but at the same time AC length also is increasing. So though your acceleration is high, but because of AC length increase, the time taken will not be minimum. So that is the reason we should go only for that getting a function, getting an equation where t comes as a function of alpha. So okay, we will write the equation of motion on this. AC will be half into a into t square, right? Because initial velocity when it started from a will be 0. So this equation, you know, AC is equal to half into AT square. So from here you will get T is equal to 2L sec alpha divided by G into sine alpha minus K cos alpha, and the entire square root. Okay. So this is the equation you obtained, time as a function of alpha. Now from mathematics, you know that if you differentiate time with respect to alpha and equate it to 0, you will get the minimum time, right? So dt by d alpha you do and you solve it. So this I have left it on you because this is a simple differentiation. So upon solving you will be getting tan 2 alpha is equal to minus 1 by k. Put the value of k and alpha you'll finally get as 49 degree. So this is one of the answer. T minimum is associated with alpha is equal to 49 degrees. So you put the value of alpha in this equation so that you can get T minimum, that is equal to, when you equate it will come as 1 second. So this is the second answer. So hopefully you understood the concept of solving it. In case any doubt at any stage, you can write in the comment box. I'll come back on it. I'll clarify your doubts. That's fine. Thank you.